All right, greetings, Saints. We have similar right triangles, lesson 9.3. So we're going to go ahead and get started with this lesson, and I'm going to go ahead and use my drawing tool here that makes my really handy and perfect, or seemingly perfect, triangles. So I'm going to draw this right triangle right here that's obviously going to be scaling, where I have this right here, that would be like the long leg, and this would be the short leg of my triangle. Okay, so I'm going to label the parts here where I have triangle A, B, C, and then I'm going to take an altitude right here, which is going to be D. All right, I go ahead and just take this little auto shape thing off. What we're going to find out here is that we have, as we discussed previously, is that we have three similar right triangles. Okay, so let's go ahead and or it's three similar triangles, and I hope you guys can see all three triangles. Right, we have this guy right here, this guy right here, and of course the big one. Okay, so what is the similarity statement we'd have? This kind of goes back to what you guys saw on the chapter 8 quiz. If I have this entire big guy, so this is ACB, right? Where I have went long leg, then the short leg, and then C is the vertex of that right angle. And then, of course, AB is my hypotenuse. This is going to be similar. Let's go ahead and do this mid-sized triangle. Now, if we go through here, and remember AB was my hypotenuse, then in this triangle, um, A and C has to be my hypotenuse. So then that angle in between would be D, which would be the vertex, right, of this right angle. But we have to make sure that we went AC was my long leg, right? Which means AD has to be my long leg. Let's take a look. AD, long leg here. And now let's make this make sense in terms of the similar parts, why this would be similar, right? Because I have C and then D right here. These are going to be the first two angles. And then we're going to say that A right here corresponds to, for ACB, ADC, and it's going to be that reflexive angle. So these, of course, are going to be similar through angle, angle. Okay? So let's make sure we do the same thing. We need to also utilize this right angle right here for my third triangle that's going to be similar. And we had AC was the long leg of this big triangle, right? So what's the long leg for CD? Well, it's this. Or for CDB, it's CD is my long leg, and D my right angle, right? The same way that I had for ADC. So D right here reflexively is right angle, and then CDB. Now ADC. Let's go make this guy back to talk to you how he's going to be similar with the first one. ACB. We have the right angle and the right angle. Okay. And then we have this reflexive angle, which is angle B. So we have all of our two congruent parts through angle, angle. So it creates this figure where we have the altitude creating three similar right triangles. Okay, so let's utilize this to solve a problem here. Let me draw one, and I'm going to orient it in a similar fashion here. Okay, it's going to be this. We're going to do a classic. Ooh, my goodness, that is terrible. Software can't even fix that. Get a little classic Pythagorean triple that we're going to work with right here. Okay, where we have 4 and we have 3, and I'm going to drop an altitude right here. Okay, let me turn off this thing so it doesn't foul up when I'm working with. And I want to solve for what this altitude is going to be. How could I do this? This is all that I'm given. Well, the first thing I'm going to do is I'm going to solve for this side right here, this entire side, which is the hypotenuse of the big triangle, because we have 3 triangles, right? We have big, medium, and then small. Okay? Big, medium, small. I oriented it the same way. right? Long leg, short leg, short leg. So my orientation is the same. So how long is this side right here? Well, this one's going to be 5. And some of you guys are like, Mr. Granades, how did you just give that away? Remember, this is going to be solved through a squared plus b squared is equal to c squared. I already said it's going to be a Pythagorean triple, right? So 4 squared plus 3 squared is going to be, of course, 5 squared. Okay? This was c squared, right? So it's going to be 25 is equal to c squared. So 5 is c. All right, so we have all that. We're good to go. So since this is 5, ooh, I got some weird plus signs here. Let's go ahead and kill those. Let's create a proportion, just like we would have in the last chapter. So let's take my hypotenuse, okay, to my short leg, which is 3, which would be equal to, now remember, this is my medium triangle right here, right? My hypotenuse is 4, and then my short leg is right here, right? Which is the altitude. So over x. And then now I'm just going to take a cross product. So I have 5x is equal to 12. So x is going to be equal to 12 over 5. Okay, you may recognize that actually from your chapter 8 quiz. All right. Next, fun fact. Okay, and this is a theorem that we're not going to prove together here. We may do it in class though. Let's go ahead and create a right triangle. With an altitude. Okay? So, you're going to learn a new term here. I have this hypotenuse here, which is split into 2 segments. And this is 10 and this is 4. Meaning through segment addition, the entire hypotenuse is going to be 14. I can solve for this altitude by finding what is called the geometric mean. The geometric mean is that this altitude x, okay? The altitude x is the geometric mean, which is the square root of the product of the 2 segments formed by the altitude and it's going to be at the hypotenuse. All right. It means this. Remember when you take an arithmetic mean? If I were to take the arithmetic mean of 10 and 4, the average or arithmetic mean means that we're going to add the numbers and take the quotient of the number of numbers. In other words, I would add 10 plus 4, and I would then divide by 2. We do this when you take a midpoint, right? You take an average of the x's and average of the y's. Here, geometric mean is different. What it means is that we're going to do the square root of 10 times 4, okay? And that's what x is going to be equal to. So x is going to be equal to rad 40, right? 10 times 4, which then we can take out, right? The 4 can be the square, can be 2, and I'm left with a 10 inside, stuck inside the radicand, and that is my arithmetic mean, 2 rad 10. Let's practice with some geometric mean. Sorry, not the arithmetic mean. That's my geometric mean. So let's do some geometric mean practice. Oops. Geometric mean. It'd be great if you guys got a bunch of these on the next quiz, right? I think you guys would like this. Like, what's the geometric mean of 6 and 25? Okay, take a moment. It means we need to do 6 times 25 and take the square root of that, right? So it's the square root of square root of 150, or rad 150, which is equal to, well, 150 has 5 as a factor, so we can go 5 rads, or 25 as a factor, so we can go 5 rad 6. Okay, let's do another one. Geometric mean of 6 and 7. All right. It means it's going to be rad 42. right? The square root of 6 times 7. Can we actually pull any factors out of that? Does 4 go in? Nope, right? 36 doesn't go in. It's too big. It's more than half. 25 doesn't, right? So that's what it's going to be. How about the square root of, or the geometric mean of 10 and 25? Well, it's going to give me rad 250, which you can reduce to 5 rad 10. Okay, I think some of you guys are even seeing, like this has got is already going to be a square number, so that's going to come outside the radicand right away. So let's do a little bit more here, a couple more problems. I'm going to figure out what this height is. Okay. We got 25, and then we got 60. All right. So how am I going to do it? Well, I can figure out what this entire segment's going to be, and then I'm going to take a similarity of it, right? So then I'm going to take 25 squared plus 60 squared, and that's going to be equal to x squared. This is my x that I'm going to solve for. All right. And of course, I'm going to show you guys on a calculator. 25 squared, 625. And 60 squared is 3,600. And that's x squared. According to my calculator, 625 plus 3,600 is 4,225. Let's just try it. Who knows? Maybe that's actually going to be a square number. Square 4. Here we go. It's 65, right? Square root of 4,225. Sweet. So that one would be in a Pythagorean triple. That's pretty cool. All right. So this entire thing is equal to 65. Now, think about this. I'm going to go long leg to short leg, 25 is equal to, right? And on this triangle, we're going to go long leg to short leg. Guys, sorry, this is hypotenuse to short leg, okay? Hypotenuse on this triangle to the right, 60 to h. Take cross product, right? 65h is equal to 60 times 25, which is 1,500. And divide both sides by 65. And then that can reduce, what's going to go into those? Both of those 5 can go into both, right? So 300, 1,500 divided by 5 is 300. And then 65 divided by 5 is 13. And that's going to be your answer. 300 over 13. All right. Last one. Here we go. Yeah, so let's get a fix here so it's not just so sloppy. All right, I've got y, and I'm solving for which I got 2 and I've got 5. Okay, so how do I do it? Do I do a Pythagorean theorem? Nope, remember right here. This guy here is the geometric mean. It's the altitude. So geometric mean means that we take the square root of the product of the two numbers. So the square root of 2 times 10 or rad 20. And we're not done. Rad 20. Gosh, guys, 2 times 10. It's 2 times 5. I'm really bugging out here, guys. It's getting late in my evening here. 2 times 5 being 10. So rad 10. Okay, excellent. That's why I use a calculator. It verifies for me, just in case my brain is struggling a little bit. So, gentlemen, good luck. Come see me during office hours.